Hello, everyone. Let's get started. Welcome to today's meetup. My name is Dalia and I'm from Elastic's community team. Today we're here to hear from Joe. He's a senior software engineer from Elastic, and he's going to talk to us about data exploration using Elastic Stack for beginners. We're going to take all of the questions in the end. So if you can please ask them then. And yeah, go ahead, Joe.
Thanks. So hey everyone, I'm Joe, and I'm going to talk about data exploration using the Elastic Stack for beginners today. Okay, so for folks who don't know how Elastic Stack works, here's the summary, the upshot of that. Elastic Stack is a relatively general purpose collection of software components which can be used to store data, to search on it, analyze it, and visualize it. And it always works like this. So you have some kind of data source there. This can really be almost anything. So it can be the log files generated by a web server like Nginx. It can be existing data tables stored in a SQL database like Postgres. Then there are modules, components of the stack to load this data into the database. So for the logs, for known applications like Nginx, there are the so-called beats, which make this really simple and lightweight. And then there's Logstash, which can work with almost anything, and it can also run transformations on top of the data before it's ingested into Elasticsearch. Elasticsearch is the center of the stack here. It's the actual database storing the information. And on top of that, we have the web frontend Kibana, which allows you to query, view, analyze the data stored in Elasticsearch in a really easy and straightforward way. Right, so when you're doing data exploration using the Elastic Stack, then you complete a bunch of steps. So of course, first you need to get your data into Elasticsearch somehow. We'll see one way how this works in a second, but there are really a multitude of ways depending on your exact use case. If it's in there, then it's really simple. You can just start exploring your data, looking for interesting patterns or things to find in there using the Kibana frontend. And while you're doing that, you will very likely encounter some situations where you want to clean up or transform your data in different ways, because as you probably know, production data is rarely completely cleaned up and just ready to consume right off the bat. And once you've done that, and once you have found some things you want to continuously monitor, or you want to some findings you want to share with the rest of your company, you're going to productionize what you did somehow. This can mean different things. It can mean having an alerting setup that notifies you if some measure, some KPI passes a threshold. It can be a nice looking PDF report you're showing on a big screen in the entrance of some building, all of that. Elastic Stack is set up to do all of these things, and it's especially made for continuous data streaming. So in a lot of other contexts, you have a static piece of data, and then you manipulate it in some way, and you move it around and transform it. And in the end, you don't know what you did. Elastic Stack is different in the way that it's very hard to do this, and what you're doing along the way is mostly setting up a pipeline which you can let run over time and continue to ingest the most up-to-date data. So if you're looking for web logs, then you will just, if you have set up everything and looked at your existing data set, then you can just continue streaming in live data and look at it in a dashboard in real time or in near real time. So you define that pipeline once, and just continues to run and continues to update itself without much manual intervention. Okay, so I'm showing some demo in this talk, and the demo I'm using is a data set about used car offerings on Craigslist. So on Craigslist is a website where you can it's similar to eBay but not as structured. So you can post some offerings there. Hey, I want to sell my used car. It's a Ford and it costs that much dollar and was produced in that year, and so on. And in this data set, someone built a scraper and fetched all of this data of Craigslist for over a period of time, and put it all in a CSV file in this case. And now we want to look at what's in there and what patterns we can find in this car offerings data. So in this specific case, my pipeline will look like this. There's a CSV file which contains all of the data, and then Logstash will pick up that file, transform it into something Elasticsearch understands, and it will push it into Elasticsearch where it will be stored, and we can just use it from within Kibana. The nice thing here is you could just replace the cars.csv file with a live scraper that pushes data to Logstash if later on if you have everything set up. But let's just look at how this works with an offline data set. All right. So in this case, I have a CSV file that contains all of my data. In this, I think it's roughly 1 GB in size. So it's not too small, but it's also not super large. If we look at a file, we can see there are a bunch of different attributes for each of those car offering, which got scraped from the website. So there's a price, there's the year the car was manufactured, there's a manufacturer, there's a number of cylinders, fuel type, odometer, size, and so on and so on. And if we go down here, we can see the actual data, which looks pretty messy. So this is definitely not a nice way to look at our data. All right, to get it into Elasticsearch, we can use Logstash. So if you have a single file, then this is the easiest way to pick it up. To use Logstash, what you have to do is to define a pipeline configuration. And in here, you're basically saying, okay, this is where my data comes from. This is how I want to transform my data, and this is where my data is going. In this case, the data is coming from a local file on my local system here. And the transformation I'm doing, it's really, really simple. So in real world use cases, this gets much more complicated quickly. I'm parsing it as CSV, and those are the different columns I have in my data set. And then I'm transforming it a little bit by parsing price, year, and odometer values into numbers, because in the CSV, they're actually strings, but of course we want to use them as numbers. And the result of that, I'm just piping into Elasticsearch into a separate index, which is called cars. So I can let this run. It will just pick up the file and go through the file, but it would be very easy to use a different input here and stream data from somewhere else and use the same configuration on all other levels. So for this example, I already did that, and all of the data got ingested in Elasticsearch. And to look at that, we switch over to Kibana. So this is the Kibana interface. You can do lots of things here. As you can see here, there are tons of apps you have available. But the interesting one in this case, so the thing most people get started with when they ingest data Kibana the first time is Discover. So Discover is an app to look at the individual documents which are stored in some index, in this case in the cars index. And as you can see here, you can scroll through all of your documents. There's roughly 250,000 documents, and we can see all of the different attributes here just as we saw them in the CSV file. So they got parsed successfully, and now they are stored here in Elasticsearch. All right, so currently we're looking at all of the attributes for each single offering, and this is hard to parse. So let's add the most interesting ones as separate columns and look at them at a table. So for example, we can add the type, which is the type of car. So for example, truck or SUV or sedan. And we can add the cylinders, which is the number of cylinders. So we have 8-cylinder cars, 4-cylinder cars, and so on. As we can see here as well, there are some missing values. This means the scraper couldn't find any information about this attribute when they scraped an offering. So it's not 100% complete. This is also something which happens quite a lot in real world use cases. And of course, every step along your pipeline has to deal with that somehow. So let's add a few more. There's also the paint color. So we can see here paint color is in this little summary. You can see here, this is just a textual description of the color in our case. And of course, we might be interested in the price of the offering. So how much does this car cost? Okay, now we can see more documents here. It's much cleaner now, but still looking through 250,000 entries like this will probably take too long. So what we can do here is to to scope down our the number of documents we're looking at by searching. We can either use a so-called KQL language to do this, which is similar to the where clause of SQL, but we can also just add a filter using this UI here. For example, we can say we're just looking at cylinders at 6-cylinder cars. And if we save this filter, then the view will update and we're only looking at the 6-cylinder cars, which are just 30,000. So this is a lot as well. And with the cylinder specifically, we encounter a first issue in this data because the cylinders field is actually not really nice to consume because it contains a string saying 6 cylinders. So Elasticsearch doesn't know this is actually a number 6, but it's just a string. So what I cannot do is to just to simply filter for 6 cylinders and more, because I would have to specify each single possible value. And if then it's something, if then the scraper picks up a car with 24 cylinders, then it probably wouldn't be in that list. So what we should have done is to parse out this number during the Logstash ingestion, but we didn't. This is not a problem because for simple transformations, you can also do them directly in Kibana. In this specific case, when you want to change how a field is interpreted and want to parse out something or want to change something about it, you can use so-called scripted fields, which are just acting on the real fields and produce a new field which you can use everywhere in Kibana as if it would be saved along with the actual documents. To do so, we switch to the stack management and then select the index patterns. Now we can see our only index pattern in here, which is the cars index pattern. And then we can see here our fields, which are the actual fields which come from the CSV file. And we see the scripted fields. I already created that prior to the demo to save a bit of time. In that case, we call that field cylinder number, and it's defined like this. Scripted fields are scripted in the Elastic Stack using the so-called painless language, which is a dialect of Java. And it's relatively easy to pick up. The syntax is a bit easier than Java, and you can do lots of things with it because it's Java. As you can see here, we are first checking whether there's actually a cylinders value in our data, because not all of the documents have one. And then we parse them out using integer.parseInt, and we just take everything from the string in front of the first space. We can check whether this works by clicking this link and then switching to the preview results. And as we can see here, we're passing out just fine the actual number for each of those of our documents. So this worked fine. And switching back to Discover, we can use this field instead. So instead of using the cylinders field, we use the virtual scripted cylinder number field. And as this is a number field, now we can use is between. So we can do a range on this field and look at everything above 6 and maybe up to 15. Right, and now you update it. Now we have 50,000 hits, and we can see there are also some 10 cylinders. We probably would have missed that one because it's pretty rare. We have 8 cylinders, 1, and so on. So this is a simple trick you can use to clean up your data in easy ways. If the data is already there, but it's somehow not accessible, then you can use scripted fields to look at them. All right, so we have that now, but it's still relatively hard to work with that, but because there's just way too much data to look at it individually. So as it is most often the case with big data sets, to get a feeling for it, you need to aggregate and then visualize those aggregates. And this is basically all what Kibana is about, except Discover, and you can do it in the dashboard. So when switching over to dashboard, we're creating a new dashboard. This will be our playground for the exploration of the data. And in here, so in a dashboard is basically just a collection of panels, and we can create new panels by using this create new button. There are various visualization types. For this demo, I'm going to focus on the lens visualization types because it's specifically suited for quickly getting an overview of how your data looks like. The other ones are more flexible in some cases, but they require much more knowledge about how Elasticsearch aggregations work to use effectively. All right, so let's just get in here. By clicking on lens, I get dropped into the lens editor, which looks pretty similar to Discover. And in here, I can just drag my fields like before. It's have my fields like before, and I can just track them to visualize. So for example, visualizing the number of cylinders and tracking the cylinders field. And what I get here is a pie chart, a bar chart for the different numbers of cylinders. You can see, okay, 6, 4, and 8 cylinders are pretty common. I have tons of options here what I can do with this chart. For example, in this case, I would like to view it as a pie chart because this type of data is commonly viewed as a pie. So I can just switch over here, view it as a pie chart. So this is a nice chart and it actually tells me something, tells me almost all of my offerings are either 4, 6, or 8 cylinders. So let's just save that. And it gets added to my dashboard. So a dashboard doesn't make much sense if you just have a single visualizations. So let's add more than those. For this first chart, we just looked at a single attribute, but in the most interesting correlations and most interesting patterns in your data will be in the interconnection between different attributes. And we can do that as well. So we can just drag in another field, for example, the type field, which tells us about the type of the car. So we can see here there are a lot of sedans, some SUVs. And now we want to cross-correlate that with the cylinders. So we just drag in the cylinders field as well. And what we get here is a chart of the different types of car split it by the number of cylinders. So this is already finding here. We can see trucks there are almost no trucks with just 4 cylinders. They're mostly 6 and 8 cylinders, which kind of makes sense. Okay, let's save that as well. Just gets added to my dashboard. All right. So for both of these charts, we just look at the count of documents. And this might be interesting, but it's in most cases, you want to look at some numerical values of your attributes. And in this case, the most important one is the price, of course. So let's check out the price. And to get that, we can just start like we learned it. So we drag in the field and we get the price. In this case, this is just the overall average price of a car in our used cars data set. Let's save that as well. Don't have to make that big, so let's slow it down. Okay, so this is the average price, but also here we probably want to break it down by something because just a single number doesn't tell you much. So let's create a new visualization and look at the price, but in this case by paint color. So we track in the paint color field. This gives us the number of the color of the paint colors for all of the car offerings by the count of documents we have, and then use the price to get something more interesting. So now what we got here is the top values of paint color, and on the y-axis we have the average of price for each of them. So let's save that as well. All right, so this is actually pretty interesting because red cars cost on average $300,000. That's a lot, especially thinking about this being used cars. So what's up with that? It seems like we have some anomaly in our data here, and to find that, it's the easiest way is to switch back to Discover because we can look at the individual documents there. We'll just remove the cylinder filter for now. So it seems like there are some really high pricey cars. So let's just sort this list by price. And if we do this, then okay, there we can see there are some cars costing multiple billions of dollars. Then there are a lot of cars costing millions of dollars. So those probably don't make any sense to consider. And they're probably outliers in some way. Maybe some user just put in a random number there, or it got not parsed the right way. In real world data sets, you will always encounter things like this. So we can, of course, we can now go back to the Logstash config and filter out those values, and we probably should, but for now, let's just add a filter to do this for us. So we pick the price field and we pick a sensible range here. So only show me the cars between $0 and let's just cut it off at 250,000. I don't expect there being many real offerings above that value, so it should give us a good idea about the biggest part of the data set. All right, so if we do this, then we see the number of hits didn't drop much. So this is really just filtering out outliers and not removing half of our data set. So this sounds good. To use this filter somewhere else, let's just give it a small label so we know what this is later. And pin it across all apps, which you can do in this context menu here, to be able to carry it over to the dashboard. If we switch to the dashboard now, then the filter got carried over and it's automatically applied to all of our charts. And now we can see here, the average price dropped to 13K, which makes much more sense for used cars. All right, let's do some exploration here. So when I'm looking at the paint color, okay, I actually see this, there's not much movement, and actually there are a lot of colors missing. So first things first, let's look at a few more top values there, just scaling up the number of values by editing the visualization. All right, saving it again. Okay, this looks better. As we can see here, there's quite some difference between cars, between orange cars with a high price of over 9,000 and green and brown cars, which are at the tail end of this distribution. So that's interesting. Let's look at the orange cars and how they are made up. So if I'm clicking a bar in any of these charts here, I will filter down all of the other visualizations as well. So if I'm clicking this orange bar, then I get a paint color orange filter, which is applied to all of our charts. So we can see the average price jumped to 19,000. We have a little bit different distribution for the number of cylinders. And we also have other types of cars which are more common. Actually, I didn't pay attention to how this changed. So let's just go back. Let's just go back here. All right, so if we look at all of them, then we can see sedans and SUVs are most common ones, and there are just a little few coupes listed. If I'm adding the paint color orange filter, then I can see, okay, still a lot of SUVs, but coupe jumped a lot. So it seems like coupes are pretty expensive. Also, when looking at the distribution with the cylinders here, it seems like there are a lot of 8-cylinder cars, which means they're pretty beefy. So this might explain the price. Actually, let's drill down further in that and see how much difference the number of cylinders makes. So we can also do this by clicking the bar, just as before. So in this case, it's asking us whether we want to filter by coupes or just by cylinders. I'm going just for cylinders now because I want to see whether it makes a big difference on the price. So filtering by that, you can see, all right, the average price jumped from 19,000 to 26,000. So it seems like the number of cylinders is pretty significant for the average price of the car. But maybe it's just an outlier for the orange cars because we still have that filter. So if you click something, filters always get added. So we can, of course, we can also remove it. In that case, let's remove the orange paint filter. And now we can still see in this distribution, okay, orange is still very close to the top, but we can see here purple 8-cylinder cars, to be precise, are even more expensive than that. So let's just look at the purple cars in that case. And if we filter down by that, so we see an interesting thing in the type view here, because there are a lot of other typed cars, so we don't know exactly which type this is about. Then there are some trucks and coupes. So at this level, it might make sense to switch over to Discover again. To do this, we can just pin all of the filters like this, and then switch over to Discover. This will carry the filters over, and now we can look at the actual documents. So in this case, we have just 49 hits. So this is the number of documents you can meaningfully look at in Discover. And yeah, now we can drill down further on that. Maybe we are looking at the model of the car as well. And maybe we can also check the condition of the car. So now we can drill down there. Okay, so it seems like, so most of them are actually not that high priced. So there are some 36 ones, but then there's a bunch of 90K cars. And actually, a few of them are cameos and they look suspiciously similar. So we can look at the actual data set. This Chevrolet Cameo can be yours today. And the second one, exactly the same description. So maybe we have a problem there in the data and these are duplicates. So this is how you can, yeah, it's often not an interesting pattern, but it's just some problem in your data. But anyway, we discovered this thing. So this is how you can move between the high-level aggregations and low-level documents to go through your data. And if you go through your data like this and you have some interesting findings you want to you retain for the next data analyst looking at this, then it's always a good practice to note this down somehow. You can do this using the markdown visualization. So in this case, we're adding a new visualization, but not picking lens, but the markdown visualization from this list. That's not really a real visualization type. It's mostly about noting down some text with a little bit of formatting. So for example, we can note down our color findings. Purple and orange cars are really expensive, especially for coupes. And we can maybe also mention our sanity filter. There are some crazy expensive cars. They shouldn't get indexed in the first place. Right. By updating, we can look at how this visualization and quotes will look like. And if you're fine with these nodes, then we can just add them to the dashboard. And they will be just listed out as another panel we can put side by side with our other panels here. All right, and to complete the exploration, we also have to save this dashboard. For example, we can call it the cars exploration. We did that on October 6th. And save. So this will save that in the list of all dashboards, and the next person logging into this Elastic cluster can also look it up and can continue from there. So in general, this allows you, this workflow allows you to switch between the low-level data and the high-level data. It also allows you to store what you found out in a nice way, and this can be updated without needing to rerun anything specifically. It's just about keeping your pipeline in place and keeping it running to ingest your data. All right, so this is the exploration part. We also did some cleanup. So if you want to productionize that now, so maybe you want to show the average price somewhere very central, or maybe you want to send out a report of a better looking dashboard than the one we created just now, then you don't have to do that many steps actually, because the general setup scales to large data sets as well. So all of the heavy lifting here in this setup is done by Elasticsearch. Kibana is just the UI for showing this data, and it queries the data from Elasticsearch and will only get sent the aggregates which are very low in data volume. So if you want to scale that up and handle more data, you just need more Elasticsearch instances, and you can add that to your cluster really easily. Everything else just keeps working, and you probably have to clean up some things you hacked in along the way. This is mostly about this data transformation and cleanup. So if we want to parse out the cylinder number as a number, then we should do that upfront before ingesting data in Elasticsearch, because while it works doing that from Kibana as a quick prototyping while you're exploring, and to have the full performance benefits Elasticsearch can offer, you should do this as soon as possible. So it's always a good practice to, while exploring, do the things quick and dirty, using filters, using scripted fields, and things like that within Kibana. And then once you know what you want, push that upstream and handle it in Logstash, or handle it in a so-called Elasticsearch instance pipeline, an ingest pipeline. Also, to make it nice looking for the actual consumers of your data, you can create cleaner dashboards based on the existing ones or just creating new ones. You actually have tons of options there, how to color your charts, how they look like in detail, how the axes are set up, and so on. With using a tool called Canvas, I won't go into detail right now, but you can play around with it. in various places. You can even create kind of slideshows which are all hooked up to the live data, so they will be updating live while you're looking at it once when you're ingesting new data in your Elasticsearch cluster. You can also set up some interactivity using filter controls. You can generate reports and so on. So if you're interested in doing this, the best point to start is the elastic.co website. On the subdomain demo.elastic.co, you will find a running cluster you can log into as a guest user, where you can see all of the things the Elastic Stack can handle: APM, machine learning, observability, workplace search, and so on. Loaded with lots of demo data sets. And if you don't want to download this and run it on your own infrastructure, then you can also use our cloud offering at cloud.elastic.co to get a small cluster running really fast. And if you're just looking at really small data sets below 100 megabytes, you can even import them directly through the Kibana UI and start playing. All right, so that's it for the presentation. I'm happy to take any questions you still have, and we will send around a link to a survey in the chat. If you have a few seconds to complete that, that would be great.
Awesome. Thank you so much for the great presentation. Yeah, the survey takes only like 10 seconds, and we just want to know what kind of topics you want to hear about in the future. So it literally takes 10 seconds. If you can please fill it out. And if not, we can just start with the Q&A.
Sure, so I see one question there about data ingest from Kafka. So from Kafka, you can directly hook them up into the into Logstash. You can pipe this data in there, and in that case, Kafka will just act as a queue and buffering those until Logstash can pick it up and push it to Kibana, to Elasticsearch, where you can use it. Does this answer the question?
And by the way, this meetup will be, it's recorded and it's going to be uploaded on our YouTube channel if you want to rewatch it. So I will just put the link. This is where we keep all of our recordings of the meetup. So we have many there where you can just go and rewatch them. Yeah.
Okay, there's another question about Kafka Connect. Unfortunately, so I'm a developer on the Kibana team. So if you have any Kibana questions, I'm pretty sure I can answer them, but I'm not an expert on the Kafka integration. But if you have any question there, it's very recommended to drop by in our forum at discuss.elastic.co. And yeah, there's a specific sub-forum for Logstash, and I'm pretty sure there will be someone knowledgeable answering the questions there. We also take rounds among the developers to answer these questions there.
Can we have sessions on cross-culture? Yeah, definitely. I will look into it. Thanks for recommending. And for the link, I'm posting it one more time for the YouTube channel. Anyone else? Any other questions? Well, if not, we'll end earlier then. Thanks so much, Joe, for your great presentation. And the recording will be up on YouTube in a couple of days. And hope to see you guys at our next meetups. Thanks.
Right.
Bye.
Bye.